Okay, welcome. For those who do not know me, my name is Robert Christ. I am a Siemens product specialist with Springfield Electric out of the Davenport, Iowa branch. I have been with Springfield for a little over 10 years. Um, I am a Siemens factory automation certified app engineer, as well as certified in industrial controls and Dynamics G drives. But moving on to what we're going to talk about today. Today, we are talking about the SIMATIC S7-1200 compact PLC family. To start things off, I'm going to show a short little video, and then we'll get into the details. Real quick summary of the high level processors. There in the top left, we have the S7-1500, which is the big brother to the 1200 and is considered the full modular PLC family. There's also within the same, they take the same software and can be run on a dedicated IPC application with the 1500 software controller. But then additionally, there are two controller options that are put into our ET200SP Slice IO form factor, one based on the hardware controller 1500 and one based on the software controller 1500. Moving on to the key innovations that Siemens likes to focus on within their PLC family. We're going to real briefly talk about them here and then move on to a little bit more during the presentation. Main areas of focus include security, safety, and diagnostics and technology integrated into the platform through programming, the innovative design and compact size, and then most importantly with Siemens in the TIA portal, efficient engineering through the single engineering framework known as TIA portal, which is a programming environment for PLC, HMI, drives, SCADA, network, and smart controls. When we look at where the S7-1200 sits in comparison to the other controllers within the Siemens controller family, it is on the lower end of the controller, but it comes at a very competitive cost point. Don't let it fool you. It is still a very powerful controller for its size and functionality. And it still goes down the path of the 6 features that Siemens likes to promote across their entire line. As you can see, it overlaps a little bit into the S7-1500 platform, and then you can see where the other 2 options fall within the 1500 environment. Not going to go much into this other than to say that the 1200 is very versatile for a large range of market segments. It's extremely good for OEM environments, especially smaller machines that are not an extremely big amount of IO count, but it's also been used in applications from car washes and bowling alleys. One in particular I know that Siemens is proud of is it is the primary control system for Top Golf driving ranges, and it is what helps control all the systems at the individual stations. Now, before we get too far into hardware, I wanted to just touch real quickly on the software for the SIMATIC controller platform. For the PLC side of it, the software is Step 7 in the TIA portal. There are two versions of it available right now. Excuse me. For the S7-1200 PLC family, Step 7 Basic would be all that you need. If you then step up into the larger controllers, whether it be the S7-300, S7-400, the 1500, or even the open or software controllers, then we would be looking at Step 7 Professional. I should also mention that Professional also covers the S7-1200 CPU. In addition, with Step 7 Basic and Step 7 Professional, you also get an equivalent, the HMI equivalent software, WinCC Basic, which is used to program the basic panel line of HMIs. On all of these PLCs, just as there's Step 7 Basic and Professional, there is a safety equivalent of this for use with the fail-safe controllers. Safety Basic, once again, covers just Step 7, not Step 7, I'm sorry, S7-1200F processors, while Step 7 Safety Advanced covers the full line. When it comes to the design of the S7-1200 CPU, there are some features that are common across the entire family line. Both CPUs all of the CPUs have options available on the power supply, whether it be a 24 volt DC or 120/230 volt AC variant. The 120/230 volt AC variant actually has a small power supply in it additionally that will provide 24 volt for some field sensor supply for your IO. All of the 1200s have a slot on it for a SIMATIC memory card. With the 1200, this card is completely optional compared to its big brother, the 1500, where it would be required. With the 1200, this can be used to expand the load memory of the PLC, or it can actually be used to to store additional files and uses for things like the web server. And we're going to see that a little bit later during the live demo. Additionally, the 1200 CPU has a trio of status LEDs for CPU status, including run, stop, error, and maintenance. It has LEDs for each one of the the integrated IO built onto the PLC. And it also has status indicators for the communication port on the PLC. Talking about the communication port, each one of the 1200s comes standard with at least a single Profinet connection located on the bottom of the CPU via RJ45 connection. Additionally, beyond the onboard built-in CPU, there is an expansion slot for an option board on all the models, and there are a variety of signal boards, communication boards, and even a battery board that can be added into that slot. And then finally, the 1200 CPUs feature removable terminal blocks that come standard in screw terminal, although push-in terminal blocks are now available for them that are conveniently covered behind cover flaps. When it comes to variants of the S7-1200 CPU, there are five flavors that make up 19 versions of the processor. Um, Majority of them, the 1211, 1212, 1214, and 1215 all come in 3 versions, and then the 1217 comes in a single version. Um, Looking at those descriptions probably don't make a whole lot of sense, so I'll just quickly break that down for you. The first Before the first slash in the description, so if we look at CPU 1211C and the first one DC/DC-DC, the first uh, the first letters indicate the version of the power supply that is built into the CPU. So DC for the 24 volt DC version and AC for the 110 to 30 volt version. The middle section, at least at this point in time, will always say DC, as that is the indicator of the um, digital inputs on the unit. At this point, 24 volt DC digital inputs are the only option available on the centralized base. Um, I have not heard otherwise, so for now, that's the best option. And then the third set of letters indicates whether it is DC transistor outputs or whether they are mechanical relay outputs. Like I said, the 1211 through 1215 offer all 3 of the options. The 1217 is only available in a DC-DC-DC. That unit was designed specifically for the automotive industry, and so it is designed for very special applications with its I/O. Additionally to the standard devices, Siemens also offers the 1212, 1214, and 1215 with DC power supply as a fail-safe version, both with DC or relay outputs on it. When it comes dimensionally to the 1200 CPUs, all of the lines have the same height and depth profile, and the only difference between them is the width. To look a little bit more at the, just one second. To look a little bit more at the differences between the models, looking at how the local expansion can occur on the 1200 CPU. With the 1211 CPU, with all of the CPUs, there is the option through the expansion port to add 1 board to the front of the CPU and 3 communication modules or processors on the left side of the CPU. In the case of the 1211, that is the extent of the local expansion. It cannot take any additional signal modules. So the onboard I/O and the expansion board are the only options with it. That makes the 1211 a very limited CPU, but it is great for applications where a machine will never be expanded, and that where the I/O count is where it will live forever, as there are cost advantages to that small CPU. Moving to the next size up with the 1212, we keep all of the expansion board options and the communication options, and we now add the ability to add 2 signal modules. And then finally, with the 1214, 15, and 17, we expand everything we've seen before now up to a total of 8 expansion modules. A few other specifications to point out. The 1211 through 1214 each have 1 integrated Profinet port on it. The 1215 and 1217 does add a second port. It is not a separate NIC card. It is just gives you a 2-port Ethernet switch with a single network adapter. As you move from the 1211 up through the 1217, both your work memory and load memory does increase. Additionally, through the memory card, the load memory can actually be expanded up to 32 gigabyte for additional uses. One of the other differences between the models is the number of integrated digital I/O on the model. With the on the lower end, the 1211 having 6 inputs and 4 out, the 1212 having 8 in and 6 out. The 14 and 15 both have 14 in and 10 out. The 17 has 10 in, 6 out, and then four in and 4 out that are for special uses. Additionally, all 5 variants of the 1200 offer 2 analog input points on the PLC. They are a very basic 0 to 10 volt signal. So if you have a simple analog need, they're a great input. If you need a good high resolution, I still would recommend an external system signal module for it. Additionally, the 15 and 17s add 2 analog outputs. All of the CPUs have integrated high-speed counters on them. All of them have 6 total, and with the exception of the 1217, all 6 run at 100K. With the 1217, 3 run at 100K frequency and 3 run at 1 megahertz. Additionally, all of the 1200 CPUs have the ability to support up to 4 pulse outputs. Now, there is one note regarding that. That is only on the variants that have DC transistor outputs. The mechanical relay outputs cannot fire at a rapid enough rate and also won't last long at that high rate of triggering. And so that functionality is disabled in the relay output versions. Looking at the fail-safe versions, the 1212, 1214, and 1215Fs all mirror their standard counterparts, with the exception of they have a additional work memory to handle the safety functionality. Few more quick specs. The 1200 is rated from -20 to positive 60C when installed horizontally, or it's derated slightly to -20 to 50C in a vertical application. And it also has real-time clock buffering on it via a high-performance capacitor. Moving on to signal board options, starting with the onboard expansion slot, there are part numbers available for either 24 volt or 5 volt DC inputs, as well as standard analog inputs, RTD signals, and thermocouples. Additionally, there are output boards available in both 24 or 5 volt DC, or there are analog output cards available as well. There is even a hybrid DI/DO card that has two digital inputs and a digital output. The signal board is really designed as a method to add 1 or 2 extra points to your system without having to add an extra signal module. When it comes to our signal modules, and in digital inputs, there are versions in 24 volt DC in both 8 and 16 channels, including fail-safe IO versions. And digital outputs, there are 8 and 16 channels, both in 24 volt and relay output, including fail-safe options. And there is also a 8 and 16 channel hybrid unit that there is a 8 and 16 channel hybrid unit in 24 volt and relay output. Additionally, in the hybrid model, that is the one opportunity for 120-volt digital inputs on it. At this point in time, that is the only module Siemens is offering that has 120-volt input on the units. Looking at analog inputs, there are a variety of module options in 4 and 8 channel sizes, both at 13 or 16-bit resolutions. There are cards to support RTD inputs and cards for thermocouple inputs. Additionally, there are both 2 and 4 channel analog output cards, as well as a hybrid analog in, analog out card that has 4 in and 2 out. All of the analog cards support your standard analog signals, whether it be 0 to 10 volt, 4 to 20, 0 to 20, as well as several others. The only one that does not is the onboard analog card, which only supports 0 to 10. In addition to standard I/O, there are several technology modules available for specific applications. There are modules available for load cell weighing applications. There is a condition monitoring system module, as well as a energy meter module. Moving on to other modules available for the 1200 platform, looking at communication modules. The 1200 CPU has at least a single integrated Profinet port on board, which supports industrial Ethernet, Profinet, Modbus TCP, as well as software-based communications such as OPC UA, as well, and direct connections to cloud systems and MindSphere applications. When we look at as far as the onboard expansion board module, there is a RS-485 interface available that can be put into that slot that would give you options for USS, point-to-point, and Modbus RTU communications. Looking at communication modules plugging on the left side of the CPU, there is a OSI module available, as well as modules for IO link and RFID communications. There are modules available to allow the S7-1200 to either be a Profibus master or a Profibus slave on the network. Profibus DP, I should mention. There is also communication modules for RS-232, 485, and 422, 485 serial communications. And then there are several serial teleservice modules available for phone network type communications. Looking a little more at some of the protocol options available through various cards and onboard protocols with the 1200. Besides the default Profinet, it also supports Profibus both as master and slave. Recently, OPC UA server capability has been added to it, and as well as Ethernet IP through the use of a Siemens library. As I also mentioned, OSI, BACnet, CANopen, IO Link, RFID, as well as several of the point-to-point and other serial protocols are supported. When it comes to phone type service, there are cards for GSM, GPRS, and LTE cellular connection. And there is even a module which communicates over DNP3, which is commonly used in the utility industries. One of the most interesting protocols that has just been recently added to the 1200 PLC is OPC UA, and it is a platform independent interface that allows you to directly communicate to it without additional hardware and software. It is an Ethernet-based protocol that there is software available, whether it's for other PLCs or a higher level SCADA or MES system, but it allows you to talk to the 1200. And it's not just the 1200, the 1500 is also supporting OPC UA, and it's becoming more and more common within the industry. A few more last little hardware things. There are, if you're working in a lab, there are some simulator boards that are included also with our starter kits that help you test in front of you without adding a bunch of switches. There is a memory card available that ranges from 4 meg up to 32 meg to allow you to expand the load memory. We also have a compact unmanaged Ethernet switch that is in the 1200 form factor that is 24 volt DC powered and gives you 4 RJ45 ports. Additionally, there is a power supply unit that is 120 230 volt input and gives you 24 volt DC 2.5 amp output in the same form factor. If you have the need to back up the real-time clock more than the average 12 days without power, based on their testing, there is a battery board that runs off of a coin type battery that can be put into the expansion slot to help back that up for prolonged power outages. Additionally, as I mentioned, the removable terminal blocks are screw terminal to begin with, but there are options to purchase push-in terminals if that is the preferred connection method. Additionally, if space is a premium and you don't have room for the signal modules next to the CPU, there is a 2-meter expansion cable that lets you relocate the signal modules. Touching a little bit on some of the innovative topics, starting with security integrated, Siemens has implemented a variety of options through the hardware and software to help keep the system integrity of your PLC, whether it be know-how protection, copy and execution protection, as well as additionally access and manipulation protection, and then secure communications through certificate type implementation. Looking at a couple of the technology functions that are available on the 1200, there are several options for integrated PID controllers built into the 1200. They have fairly simple to use screens for implementing and connecting up a PID without a ton of extra programming. There is auto configuration to help you set up and tune your PID control loop once you have your physical connections, and then easy commissioning screens help you to see what's going on through the integrated trace function on the 1200 and the TIA portal software. Additionally, when it comes to basic motion control, there are drive objects for basic position and speed control of drives. Similar to the PID, they're very simple screens to get you started and step you through the options, but lets you send drive commands out, whether it be over pulse train output on DC versions, on DC output versions, or whether it's Profi drive to a Profinet or Profibus enabled VFD, or even if it's via analog output signals. Talking a little more about additional functionality, mentioning those modules from earlier, with the SM1281 module, you are able to implement a condition monitoring system using vibration sensors that can perform analysis of machine vibration and help you set conditions to determine when maintenance or equipment could be failing. Additional modules within the Cywerix line get into our weighing options with the WP 231, 241, and 251 for a variety of different weighing applications, whether it be load scales, load cells, belt scales, or even dosing and filling processes. And then finally, with the SM-1238 add-on module, this gives you the ability to acquire electrical characteristics of single and three-phase networks up to 480 volt. Um, this allows you to pull line voltages and read current, take current measurements directly into the PLC using 1 amp and 5 amp CTs, and allows you to bring those kind of power and frequency applications in through that data. One of the other innovations that Siemens is very proud of is their integrated system diagnostics. Um, I know with most systems, traditionally, in order to get a lot of detailed information out of the CPU, you have to spend a lot of time creating alarms for that system. In the case of Siemens, it's really configuring it instead of programming it. By default, these alarms and diagnostic information is automatically available. As you change hardware components or add hardware, it updates without having to change anything in the system. And these diagnostics are available even if the CPU has gone to stop. Um, the diagnostic provides detailed, clear information and is accessible from within the TIA portal itself while connected to the CPU through the internal web server of the processor, through a connected HMI in the system, or through the SIMATIC automation tool. And we're going to see that a little bit when we get to the live demo portion in a few minutes. And then finally, when it comes to features, is safety integrated. Siemens has come up with what's probably one of the smallest and most cost-effective combination standard and safety PLC in one controller. It is ProfiSafe integrated, so it can talk safety over the network. It is TUV certified up to a SIL3 application or PLE. It makes it very simple to and cost effective to extend an existing system simply with a safety processor. It adds additional protections through password for both the fail-safe configuration and the program, and it also expands the internal diagnostics with fail-safe safety data. The one note I will mention with the fail-safe CPUs is that the onboard I/O is not safety rated. It is still standard rated. So in order to get safety rated CPUs, that would have to be accomplished through signal module expansion. If you're interested in getting started, Siemens offers several options in starter kits for a quick and easy way to get started. The QR code in the middle will take you to a Siemens site that shows you the various options that are available. But just real quick, high level, all of the kits come with an S7-1200 CPU. They come in with one of those input simulator cards to be able with some switches on it. They come with a copy of Step 7 Basic for the 1200, and they come with an Ethernet cord. So you have everything you need to, short of the laptop or computer, to get started. Other options within the starter kits include a couple different variants that include different sizes of the basic panel HMI, which software is already included as part of Step 7 Basic. And then there's also a couple options that get you a safety PLC, the appropriate I/O, and the software that is needed for it. And then one last thing before we get to the demo, here are a couple QR codes. It's a very busy slide that take you to additional information online within Siemens. The top one is to where you can sign up for I believe it's about a monthly newsletter from Siemens where they talk about new product where they introduce new products and innovations that are coming out. On the right side is a link to the S7-1200 product information website. Probably most importantly, on the bottom left is a code to the TIA Tutorial Center as part of the Siemens support site. This is a compilation of documents and videos that will help you get started within the TIA portal, whether it's programming certain functions or just finding your way around. And it's a great series of videos for someone who's wanting to get started. Then on the bottom right is a link to where you can sign up for other Siemens-led webinars, typically focusing within the SIMATIC PLC automation line. So HMI's PLC, probably VFDs, but these are usually maybe about every month or every 6 weeks or so, Siemens holds a webinar related to that. And with that, I'm going to real quick switch over to my camera so I can show you the demo, and then we'll take a look at the web server functionality. Okay, there we go. What I have here is a Siemens S7-1200 demo. It is a CPU 1215 FC, so it is a fail-safe safety processor. It is a DC variant, so it has 24-volt DC inputs. It has 24-volt DC outputs, and it has a 24-volt DC power supply. As you can see by the labeling across the top, the terminals, the power comes in on the top left, and the terminals are well labeled depending on their grouping all across the top. We then have the analog output and analog input locations on the top right. Off to this side here is the SIMATIC memory card. This demo does have a card in it for to show some of the web server functionality and some of the additional information. In the bottom right, we have our DC outputs, and on the bottom left, we have our Profinet port. Because this is a 1215, it does have the 2 ports on it. You can see Ethernet status, PLC status, output status here, and then as I turn things on, you can see output status across the top. Now, give me just 1 second, and I'm going to switch over to a web browser. I'm going to show you the web server functionality. Okay, the web server in this case does not require anything special. I am going to enter it does have to be enabled. So for those worried about having external people having access, it is enabled through the software. So by default, it is not active. It would have to be started when you were programming it. But in this case, I'm going to go to the address of the PLC. And we come to this nice little splash page for the S7-1200. Now I'm going to go ahead and click enter. And you can see we come to a very basic page, not too much information here. It has a little graphic showing the indication of the main LEDs on the processor. It gives you some information such as the project name, the version of TIA portal that it was programmed in, as well as step 7 safety, because this is a safety version. It tells you some of the naming information and the type of module, and it gives you the status of the CPU. It also down in here tells you whether the safety functionality has been enabled and what the F signature of the safety program is. For those of you that do safety, that's important because that F signature changes every time something is altered inside the CPU. And so if you as a OEM or a PLC provider provide a safety system, that F signature, if you document it before you send it out, and then say 6 months down the road something's wrong with it, you can go back and see if that signature is changed, then something has been changed inside the CPU. And so kind of gives you a heads up that maybe somebody or something has altered the CPU without your knowledge. That being said, I'm going to log into the CPU. This information is set up in the TIA portal project when you do it. Now that I've logged in, it actually gives me a few more options on the main page, including being able to stop the CPU. And additionally, if you're not sure which CPU it is, you can also flash the LEDs on the front of it. It's a great way to identify the CPU if you have an application where you have multiple and you're not sure which one it is. Let's see. Looking first at one of the things we talked about, I kind of want to show the diagnostic buffer. And this information is available if you're connected to it inside a portal, or if the web server is available, this information you can get without even having to have the portal software if the web server is enabled. As you can see, somebody needs to set the time on this PLC because we're off by a few hours. But as you can see where I just set the PLC to stop, I have incoming events that show that the CPU has been requested to stop, and has gone to stop. Now, that being said, one of the things I mentioned earlier was that the diagnostics still work even when in stop. So what I'm going to do, I have a eStop hooked up on this demo that is connected over Profinet. It is a Profinet enabled eStop device. I'm going to unplug the Profinet cable, which causes an error in the system. I've already gotten an error I immediately get an error light on the CPU itself. But more importantly, as you can see here now, the top 3 events are related to this failure. Number 2 and 3 are related to the network watchdog timer having issues with not seeing communication on the device. And number 1 is specific to that it can no longer find this device. Now I click on that and scroll down, and now I have details in it that tells me I've had an IO device failure. When it comes to network, beyond that, it doesn't give a ton of information, but it does give you a hardware ID that if you have in your documentation, that hardware ID of 270 translates to my Profinet push button station. Now, additionally, I'm going to plug my cable back in, and we're going to give it a second to make its way through. Now you can see my top event is now an outgoing event that IO device has been found again. Other examples of warning. There are also within the IO, there is the ability to read shorts across outputs, as well as over voltages. I'm sorry, not over wire breaks. In this case, I'm going to turn up, I have an analog potentiometer on the demo here. If I turn it up all the way, I am simulating a over voltage on the analog input. I've just received a notice that I've exceeded the high limit of the analog card. We scroll down and look at the detail. It shows me the hardware ID 264, which in this case is the base unit. And it tells me that input channel number 0, which is the one I turned up, has exceeded its limit. Additionally, when I turn it back down and my warning light goes away on the CPU, once it refreshes, it will be back and show that has gone away. Some of the other, I'm going to go back and put it back in run now. Some of the other functionality within the web server that you can look at is there are watch tables that you can define within the portal software with information on I/O. It is not a high speed, real quick response, but it's a good way to be able to check it. As you can see, I still have my 4 switches on from earlier. And if I turn switch 0 and 2 off, it will refresh in just a second and you will see that those are off. Now with the watch tables, these have to be predefined in the program when you are writing the code. But one option you don't have to pre-program is we can go to tag status and enter a specific address or variable. In this case, I'm going to enter I0.0 and it tells me that it is false. I can also turn it back on. I click refresh here and we can see it's on. I can turn it off, refresh, and I also have the ability to modify it temporarily here. And it will modify for 1 cycle. Like all things, these are not force tables. So if there is something else within the code, whether it is hardware or software that is overriding this input or output, it will go back after once. Additionally, the web server has the ability, if you are HTML savvy, the web server also has the ability to run basic web pages on the device. Sorry, it's taking a second to load here. Okay. In this case, this is just a little PID simulation. Let me see if I can. There we go, where we can see it all a little better. Right now, because it's off, it is tied directly to the potentiometer on the analog input 0. I'm going to, if I can get my screwdriver on there, turn it up a little bit. I can't. Hold on now. There we go. Turn my set point up. And as you can see, the internal simulation is bringing it in line through the PID controller back to get to the set point. Additionally, they have it set up where they can switch the control source signal for the PID simulation by turning this on and setting a speed point with a slider. And we can see how that also works. Other information that is available through the web server, if we go to the diagnostics page, there is additional information if put in through the program, such as plant designation and identifiers. The serial number of the CPU is located there, as well as the hardware number, order number. Additionally, it will tell you the hardware and firmware numbers of the CPU. Additionally, if there are know-how protections and things like that loaded into here, it is listed here. You can also look to see what kind of percentage of your load and work memory is being used. Additionally, from here, this is another location where you can see the runtime signature and runtime times of the safety program. Additionally, when it comes to maintenance features through the web server, once we go into the 1200 station here, you also, oh, I clicked too far. Sorry about that. You also have the ability to do, if the web server is enabled, to update the firmware of the PLC. Once the file is downloaded from the Siemens support site, it can be brought into here and then updated. Additionally, The web server allows the ability to create a backup of the CPU, which then could be restored to another CPU if needed. And then there is a file browser for, in this case, the memory card that we have loaded on here. In here, things like data logging and recipes are stored on this data, on this memory card, as well as files for the website browser, and even some small documents. As you can see there, I can open it directly out of the web server. Hold on a second. My computer did not like that I tried to share that. Sorry. There we go. And with that, that pretty much covers everything. I just wanted to thank everyone from attending today. And like I said, once again, join us on August 4th for Synamics V20. And I'm going to see if there are any questions and answer those in just 1 second. Okay, I do have one question relating to the failsafe CPU. Is that limited to just the onboard or local rack IO? No, that is one of the things that is the advantage of the S7-1200F CPU. Like I mentioned, the onboard IO itself is not safety rated, but the local rack IO can be when safety modules are purchased. But more importantly, the 1200F can be used with our safety rated remote IO platforms such as the ET200SP. Additionally, and it's not quite available yet, but hopefully by the end of this year, we are going to be able to see a functionality called share device on the ET200SP IO that would allow you to split the IO between say a safe and a non-safe processor on multiple protocols. One of the biggest applications I can see for this is what it will allow is for the non-safe IO in a Rockwell system, you would be able to have remote IO on a rack that is communicated to by the Rockwell PLC. And then you could put a small S7-1200F to add safety to the system next to it and communicate to the safety IO of the rack with the 1200F. Additionally, with some of the Ethernet IP library, there would then also be able to have communication exchange between the Allen Bradley processor and the Siemens processor. And that kind of comes back to one of my other thoughts on it was the native Ethernet IP. The 1200 does not have Ethernet IP native, but because of the industrial Ethernet protocols that are built into it, there is a library that has been and is being developed by Siemens to help come up with a better way to communicate the two and make it simpler to make connections. If you have an application where you think you could use that kind of instance and have a Siemens and AB processor talk to each other, please reach out to us and we will get Siemens involved and see what we can do with it. It's, from what I understand, it's definitely possible. It's just, it's still very early in that stage right now. So with that, I am going to wrap up. I appreciate everyone's time today, and I hope to see you again on future webinars and hear from you soon. Thank you guys very much. Have a good day.
Thanks, Robert.